Alright, sorry, I got a little ahead of myself. Here's the picture. This is for number 9. We're doing 9 through 12 right now. And what we did was we drew the thing out. We said they give you a P, which is 8. That means PC is 8, PE is 8. They tell you BQ is 5, so these two are 5 as well because they're all radius of the circle. They also tell us that this angle right here is 45 degrees. So I put that right there. And what else did we say? This thing right here is a 90-degree angle because when I have a radius drawn to the point of tangency, so C is the point of tangency right here, it's a right angle. So is at point A, so is point B and point D, because the radius drawn to the point of tangency is perpendicular. All right, that's one of the things that we learn. It's one of the things that we're supposed to study and understand. All right, they tell us this is 45 degrees. I'll tell you what, let's just list everything that they ask you to find. What is that? F, Q, D. Just put it up there. 11 is DQ. Or DG, sorry, not Q. And then 12 is arc DF. Now when it just says CG and it doesn't have anything over top of it, what is it asking you to find? We learned this at the very beginning of the year. The length of the line segment, that's right, CG. So I'm trying to find that length right here. A lot of you guys you're thinking way too hard. Let me just show you real quick how to do this. That's right. If that's a 90-degree angle and that's 45-degree angle, and I told you yesterday that triangles aren't necessarily drawn to scale. All right, so it might not look like it, but go by the numbers. This is what I mean when I say go by the numbers. This is 90, this is 45. Look at this triangle, PCG right here. Do you see that? What does this angle right here have to be? That has to be 45. Now look, if that's 45, tell me about this one right here. That's 45. Look, if that's 45 and that's 90, what's this one in here? 45. Okay? Got on a little roll right there, didn't we? Everybody see that? Okay, now watch. What's true about a 45, 45, 90 triangle? Okay, the sides are the same. The legs, okay, the two legs of a 45, 45 are exactly the same. So, look, let's just do this. Let's grab this and put it right here. Here's just an example, right, of a 45, 45. And we've talked about this before. Again, this is thinking outside the box. This is not, we didn't necessarily in this chapter do 45, 45, 90 triangles, but I kind of expect you to know that, right? If we learned it before in the past, I expect you to remember it. So 45, 45, what's true? The two sides are equal to each other. So look at this. So this side is 8 right here. So this side, this leg, I should say, and what else? This leg should be the same. And that's CG, isn't it? So without doing any math at all, basically no math at all as far as the 8 is concerned, what is CG? It's 8. That's all there is to that. All right? Let's go DG this time. All right, because that's another length. Look at DG. This is also a 45, 45, 90 triangle, isn't it? So look, I know this side right here of the 45, 45, 90 is 5. Then what is DG? That's 5 as well. Again, without really doing any math at all. That's all there was to it. Isn't that pretty simple? Yeah, but you got to realize stuff though. I mean, the math was easy because there was really no math. But you had to realize that it's 45, 45. Both the legs are the same. That's what you had to figure out yourself. Okay, that's thinking a little outside the box, a little outside the circle, we should say. Okay, so FQD. Let's find where that is. Let's go a different color this time. So it's already marked FQD. Yeah, look at that. We already figured it out, didn't we? That's right there. So that's easy. That's just 45 degrees. We already talked about how to get that. And then arc DF. Well, this is arc DF. That right there. And look, this 45 degrees is a central angle, isn't it? What's true about the arc cut off by the central angle? It's exactly the same. So this arc right here has got to be the same as that central angle. So that's 45 degrees as well. And there it is. That's how you do those 4. Started off looking like it was the hardest problem out of all of them, but really it's probably the least amount of math that you had to do on almost every single one of those problems. What's that? Yeah, well, there's an arc over top of it, so it says the measure, find each measure. So when you see an arc symbol over top of it, it's talking about the measure of the arc. Okay? When it just says CG and there's no arc over top of it, you have to understand that that means the length of CG. That was probably one of the first things we talked about in geometry this whole entire year, was when you don't see a symbol over top of it, it means find the length of that line segment. Okay? I realize you weren't here at the beginning of the year, but but you were here for this arc thing, though, right?
Right.
Okay, so you did know that. All right, let's keep going. 13. Let's say, here we go. Here we go. Here's number 13. Here's number 13. So we're trying to solve for x, and they say that's perpendicular, so it hits it at the tangent, doesn't it? So it kind of looks like you got a right triangle. It looks like Pythagorean theorem. Do I go 4 squared plus 6 squared equals x squared? No, because 4 is just from here to here. So what's the whole length? It's 10 because that's got to be 6, right? So look at this. And look how easy the math is now. What kind of a triangle is this? It's not just a right triangle. It's a special right triangle. What kind? It's a 3, 4, 5. Okay? You say, well, wait a minute. I don't see a 3 or a 4 or a 5. Well, I see a 4 here. But it's a 6 what? 6, 8, 10, right? It's just double 3, 4, 5. So x is 8. Just like that. Hardly any math at all. And see how quick? You could do Pythagorean theorem, sure. But look.
I did 7.2.
Okay, 7.2 is not 8. This is exactly 8. This is exactly 8. What? You did. Did you just write it there? I think so. Yep. Okay, here we go. Let's go a different color here. We're trying to solve for x. These two are tangent to the circle. Now remember, it cuts off some arcs, doesn't it? I'm not going to trace them, but you've got this. I'll tell you what. Let's just so at least we can refer to something, okay? Look at arc ABC. Everybody see that? I had people asking me even during the test, well, we can't do this because we don't know arc ABC. Well, you're right, you don't know arc ABC, but, and I gave a hint, I think to somebody, I don't know. I said, what if this right here was like 100? What would arc ABC be equal to? 260. How'd you do it? What was the math that you did? 360 minus 100. But you don't know it's 100, do you? But you do know it's x. But you do the math exactly the same. So this is going to be 360 minus x. So this arc is going to be 360 minus x. All right? I remember talking about something very similar to this in class during this chapter. Okay? We have discussed that. Look back on the YouTube. It's probably on there somewhere. Okay? So we have talked about that. Now, what's the rule? You got to know the rule. When the two tangents intersect outside the circle, the angle is equal to half the difference of the two arcs. Okay, so you got to subtract the two arcs. Well, what's this big arc right here? 360 minus x. And then you got to take away this smaller arc, which is x. And now you just do some algebra and then you solve for x. And I kind of expect you to be able to do this algebra. All right, you come into here, have an algebra 1. This is algebra 1. You should be able to do it. Watch this. This is the easiest way to do it. Get rid of the half. Multiply by 2. All right, so that's 70 equals. Let's do this. Let's add some like terms right here. So I've got 360, what? Minus, what's negative x minus x? It's minus 2x. All right, so that's what you have to know. Add a 2x to both. You could do it either way. You can subtract 360, but I'm going to do it like this. Watch. And then subtract the 70. So what is that? Did I do that right? Well, it's 290, right? And then divide by 2. Is that the right answer? That doesn't seem right. I think it might be. Is that right? Yeah, that's right. That's 145. Well, it's not negative. It's not negative because I divide by 2. Because watch, I added a 2x to put it over here. And then you could do it the other way. You could subtract a 360, but then you have to divide by a negative 2. All right? And you're still going to get a positive. So what is that? That's 145. Is that the answer? Is that what x is? What's the answer that I wrote down on your paper? 145. Okay, that's what I'm asking. 145. Oh, that's right. I didn't write down. Right, because I was thinking, you're right. I didn't write down the answers. I guess I should write down. Well, that's right. I'm going through them all anyway and showing you what they are. So it would be 145. That would be your answer. Okay? Glad I didn't record all that. All right, so look at this. We want to solve for this arc right here, but in the problems, when we first did this, this was usually x, wasn't it? But again, you got to think outside the box just a little bit. All right, what is this angle inside here? Well, the angle inside of there is equal to half the what? Not the difference of the two arcs, but the what? The sum of the two arcs. Okay. See how this cuts off 110? This 80 also cuts off this x. It's the sum of those two arcs. If that looks completely foreign to you, that means you didn't study this, okay? Because this was definitely one of our big major theorems that we talked about. All right? And now it's just a matter of just solving for x. Look, I wouldn't distribute a half. I would multiply by 2. That's a lot easier. Now you could distribute a 2, 110, subtract a 110, and you're done. X is 50, and that's your answer right there. That's all there is to it. That's 50. Okay? So what did we get up to? We got up to 15, so hopefully in my other class I'll go 16 to 20, and I might even start on number 1 and go through the rest of it. So in the next couple days, check YouTube, and you'll see the rest of the problems on there.